Here we go, continuing section 5.3, beginning with problem 27. So I'm going to rewrite it down over here. Integral from 0 to 1 of u plus 2, u minus 3, du. Recognize these are really dummy variables. Since these are all u's, we're treating it just as if they were x's. Now for this one in particular, it'd be easier for us to multiply it out. Since this is not obvious what function would give me this as a derivative, if I multiply it out, I'd have u squared minus u plus 6. And this is easier for me to think about antiderivatives. What function would give me u squared as a derivative? Well, it would be u cubed over 3. Minus what function will give me u as a derivative? It would be u squared over 2. What function will give me 6 as a derivative? It'd be 6u. Evaluated from 0 and 1, so we're going to plug in the 1, get a number and subtract off when you plug in the 0. So that would be 1/3 minus a half plus 6. When I subtract off the zeros, everything zeroes out. So there you go. So it's going to be 6. This right here is 1/3 minus a half is minus. It'd be 2 6 minus 3 6, so minus a 6th. And so it'd be, I don't know, 5 and 5/6, however you want to write that down. That's a mixed number. Maybe it's kind of weird. Maybe we call it 35/6. All right, then we have problem 32. Let's go to the other side. Problem 32, let's write it down. Good practice, even though I have it right here. Problem 32 is the integral from 0 to pi over 4. Now, it's good practice to write it down each time, since it really makes sure you pay attention to everything in there. Perhaps you just recognize that the secant function gives me secant tangent as a derivative. If you didn't remember that, there's other ways you could have gotten there, changing things into terms of sines and cosines, etc., but it's really just easiest to know it. If that's not obvious. All right, secant from pi fourth, between 0 and pi fourth. So we're going to plug in pi fourths to the secant and subtract off when you plug in 0. Now, it could be helpful to remember that the secant is 1 over cosine. So if it did 1 over cosine of pi fourths, then it could be easier to think about your unit circle. So it'd be 1 over root 2 over 2 minus 1 over 1, which is 2 over root 2 minus 1. Maybe I'll just leave it like that. Good. So our last two problems are 35 and 36. Let's do 35 right here. So problem number 35. I'll write it down again. 1 to 2. My variable this time is v. V cubed plus 3v to the 6 over v to the 4. Let's go ahead and make this a little bit easier to deal with by calling this v to the negative 1 plus 3v squared. Now remember, when I'm trying to do that exponent thing, v to the 0, if I add 1 to the negative 1, it doesn't really work. So we have to remember this is the natural log of v plus v cubed from 1 to 2. So natural log of 2 plus 2 cubed minus natural log of 1 minus 1 cubed. So natural log of 1, so e to what power is 1? That's 0. This is then equal to the natural log of 2 plus 7. Great. And my very last problem, let's add a page to this one, I suppose. Excuse me, for some reason it's not letting me copy and paste here. So we'll just go back to this one. I'm going to take this guy and I'm going to scooch him down so we can see him down lower. Would be another way of doing this. So problem 30, we're looking at 36. Gives us this, the integral from 1 to 18 of 3 over z rooted dz. How would I rewrite this? Well, I'm going to write it like this. 1 to 18. I'm going to say square root of 3, just bring it right there, times z to the negative 1/2. dz. Here's a trick that you can recognize. This constant's not going to change anything. Bring it out in front. All right, so what's going to give me negative 1/2? In the exponent, when I take a derivative, what would be z to the 1/2 times 2. So this is 2 root 3 right there. Root 18 minus root 1. Is there anything we could do to make this nicer? I suppose we could call this 2 root 3 times 3 root 2 minus 1. We can multiply it out, but let's just leave it there.